Hello guys, welcome to today's lesson. Can you all hear me?
Yes, sir.
Okay, and then what about others?
Yes, sir.
Okay, then there's a text. Can you all see my screen that side? Yes, it's grade 12. Yes, Nova 9. This is grade 12 lesson. So welcome to today's lesson. Let me just go to, do you guys remember that I gave you something to do at home last time we were together? Can you all see my screen there, guys? Hello?
Yes, sir.
Okay, so did you guys do these questions that I gave you last time we were together? Because I just want us today go through some questions so that we can proceed to another part of Euclidean geometry. No text. Can everybody hear me in the lesson?
Yes, sir.
Okay, so I was asking if you guys managed to attempt the questions that I gave you last time we were together. Oh. No, I assume maybe you didn't. Let us just go through the questions, guys. So we have got the question 9.3 in front of us here on the screen, saying, in the diagram, TP is a tangent to the circle, of which you can see the circle on the screen, with the center M. Okay, what's happening? That's P. Okay, it's that tangent to the circle. Then QS, which is the diameter of the circle, and R is the point on the circumference of the circle. Then the angle TPS is equal to 32 degrees. Then the first question, which is 9.3.1, is requiring us to calculate Q1, second one P4, the third one is M1, the last one is R. So as I've told you guys, with the technique, DRCPD, CPT, Dr. Captain, you will never ever go wrong. So what you're just going to do, you're going to write that DRCPT on your paper, CPT, and first check if there is a diameter on the diagram that we are going to work out with. So yes, there is a diameter, QS, and then that implies something. When you go to triangle P, which is this one, when you go to triangle, sorry, let me just do this. Meaning when you go to this triangle, that implies that this angle right here is 90 degrees, reason being angle in a semicircle. Then afterwards, you can go check if there is a radius. Yes, indeed, there is a radius in the diagram. This is our radius. This is our radius, and this is our radius too. Then this implies that these lines are equal, reason being radii, and this line, sorry. And then again, this line is equal to this line. So that is going to imply that this angle is equal to that angle, reason being a base of an isosceles triangle or angle opposite equal sides. Also, this angle is going to be equal to that angle, reason being a base of isosceles triangle or angles opposite equal sides. Then I think, okay, we are not done with the radius. There's also that theorem that is saying tangent, this is our tangent, is perpendicular to radius. Therefore, this angle is 90 degrees and this angle right there is 90 degrees. Then we can go to cyclic quad. Is there a cyclic quad? No, there isn't. But there is that thing that we maybe can use for angles in the same segment right here. That implies that angle S is equal to angle R, and this angle MQR is equal to angle P2. Okay, then afterwards you can move to parallel lines. There are no parallel lines that you can pass. Then there is a tangent, which is the last letter in DRCPT. So this is the tangent. Hello? Yes.
So, tutor, can you just explain the part where you drew the lines where angle S is and where angle R is?
Oh, okay. Do you remember that theorem of angles in the same segment or angles subtended by the same chord?
Yes. Oh, okay. So I see.
Yes, it forms shape that is like bow ties, whereby this angle is going to be equal to this angle, and this angle is going to be equal to this angle.
Okay, thank you, sir.
Yes. Therefore, in the diagram, this one, do you agree with me when I say this angle S is equal to angle R?
Yes, sir.
Okay, good. Do you also agree when I say angle MQR is equal to angle P2? Is that true? That angle MQR is equal to angle P2?
Yes.
Okay, thank you. Then we said with DRCPT, there is DRCPT, there is no parallel. Okay, there was a diameter, there's a radius, there is no cyclic quad, but we use the angles in the same segment. There is no parallel lines, but there is a tangent. Then we can just see this is our tangent. This is the triangle that we are going to focus on for now, whereby we can say this angle between the tangent and the chord is equal to the angle opposite to that chord that we are talking about. Therefore, angle TPS is equal to angle Q1, tan chord theorem. That's the reason. And then we can also have this tangent and this triangle, whereby we can say this angle is equal to this angle, reason being the tan chord theorem. Then now let us just go straight to the question and see if we can answer those questions that we are required to calculate. Question 9.3.1 is saying we have to find this angle right here, angle Q1. So how do you guys think we can find the size of angle Q1? I think we already talked about this. We know this. What do you guys think?
It's equal to 32 because of 10 chord theorem.
Okay, then she says this angle is equal to 32 degrees, reason being tan chord theorem. Okay, do you all guys agree to that?
Yes, sir.
Okay, I also agree. That's correct. And then what's the size of angle P4, which is that angle right there? What do you guys think? And then we said when we were discussing that DRCPT, this line is equal to that line. This line is equal to this line right here. And then we already have this angle. What does that imply?
It means it's a isosceles triangle, so that means it's 32 degrees because of angles opposite equal sides.
Yes, that's correct. That's correct. Do you all guys get what we just got right now? Or is there anyone who is confused?
No confusion, sir.
We can just proceed. Okay, I guess there are no confusions. Then let's go for the question 933. Calculate the size of M1, which is this one right here. There is our M1 right there. And then what do you guys think we can do now to tackle this one? In my mind, I've got two approaches. What do you guys think?
Can I try, sir?
Yeah, you can give it a try. It's fine.
Can we find M2 using angles of triangle with the P1 and P4 that we already found? And then we use M2 that we got, and then we find M1 using angles on straight lines.
Yes, that's absolutely correct. And then what do others think? Do you guys agree to that?
I think, yes. Can you try another method?
Yes, we can.
Can we use exterior angle of a triangle?
Yes, that's absolutely correct, because when we look at this triangle right here, and then this is our
Yes.
line, therefore this is our exterior angle. It's going to be the sum of those interior opposite
Yes.
angles. Yes.
Yes.
That is still going to be correct, meaning our M1 is just going to be that 32 plus 32 degrees. Do you guys get it?
Yes, sir. Thank you.
The reason being
Yes, sir.
exterior angle of a triangle is equal to the sum of interior opposite angles. Then there's also another approach, the last one I think you also can use. Can you all guys see it?
Oh, the angle at the center equals to two times the angle
at the circumference. Yes. Whereby this is your angle at the center is 2 times this angle at the circumference. Then you definitely get your full marks. Then do you all guys understand that, so that you can proceed to the last question 934?
Understood, sir.
Sir, I don't understand the angle at center one.
Okay. Okay, let me do this. Okay, with this is our circle, right? And then this is our diagram. Wherever that is the center. And then 2x, then x. Do you agree to this?
Yes.
According to theorem 2. Okay, then let me do this again. Let me do this. I'm going to try to make one side of that diagram maybe to be bit slim. Then this is the same thing as that. This is still angle at the center is 2 times angle at the circumference. Then we again can still make this right arm be a little bit slim, like this, and then you can squeeze that up until maybe it gives you something like this. Then still you can say angle at the center is 2 times angle at the circumference. Can you see that?
Yes, sir.
Are you sure?
Yes, I can. Thank you.
Okay, thank you. And then we have got the last question is saying, calculate the size of angle R. And then in the diagram, we can see that angle R is here. How do you guys think we can get the size of angle R?
Sir,
Yes.
okay, we can say angle P234 equals 90, right? Because angles in half circles. And then we already found Q1, then we can use angles of triangles to find S. And then if we have S, we can use the bow tie to find R.
I beg your pardon?
Okay, I said angle Q2 plus
Angle
P3 plus
Q2, ne?
yes, sir. P2,
Okay, what does it do?
P2 plus P3 plus P4 equals 90. Angles in half circle.
Angle in a semicircle. Oh, you're talking about this part here?
Yes, sir.
Okay, yes, that's 90. Angle in a semicircle, I agree.
And then we already have Q1 using the 10 code theorem, right? And then we can use those two triangles to calculate S using angles of triangles to find S.
Yes, to get this angle.
Yes, sir. And then we can use the S will be equal to R using that bow tie reason. Then we just find the distance.
Yes, angles in the same segment. Therefore, this angle is equal to this angle. Or you also can go for this diagram right here, and then angle R is 2 times that angle. Remember, we somehow found this angle somewhere when we were finding M1. And then you have this angle right here. Then you want this. You can just say angle M2 is equal to 2 times R. M2 is equal to 2 times R. And then you already have M2 somewhere. You just substitute that value, and then you make R subject of the formula, divide by 2 on both sides. Do you guys get this? Do you guys understand it?
Yes, sir.
So
Yes.
is there anyone who is still curious with something on these problems that we just did now? Or we can proceed to other problem? Can you all understand?
Yes, sir.
Okay. Is everyone understanding, guys, so that we can proceed? I just don't want to leave anyone behind.
Yes,
Yes,
sir.
sir.
Oh, okay, then we can just proceed to this question. Can you see my screen?
Yes, sir. You can see clearly.
Yes, sir.
Okay, thank you. So we have got this right in front of us. We have got the RCPT. Sorry. The RCPT. So you can just go to your, okay, let's just first read the statement. In the figure, which is the figure below in front of the screen, O is the center of the circle, you can see, and then the point A, B, C, D, and E lie on the circle such that the chord AB and the chord DC are equal. That implies something. Okay, you've got the chord, here we've got the chord, they are equal. There's that theorem that's saying equal chords subtends equal angles. So you already have some clue of how we're going to do this. Do you guys remember that theorem? Do you guys remember
Yes,
that
sir.
theorem? Okay, good.
Yes, sir.
Then, okay, then they're saying equal in length, and the angle AEB is the line, which is that angle right there. Okay, fine. Then we can go to our DRCPT, check if there's a diameter, then there's no diameter. Then a radius, there is a radius, which is this is the radius, that is the radius. That implies that this angle here is going to be equal to that angle. And again, we can see that this is the radius, this is the radius, that implies that this angle is equal to that angle, isosceles triangle. Then we are done with the radius. We can go to the cyclic quad. Okay, there is no cyclic quad on this, there is no parallel line, and then there is no tangent too. So we can just go straight now to the questions. Let me wrap this. The question is saying determine the size of angle O1, which is this angle right here. So how do you think we guys can find the size of angle O1?
Maybe we can try and use the theorem that states that angle at the circumference is equal to 2 times angle at the center.
Absolutely correct. Yes, angle at the center is 2 times angle at the circumference. Therefore, angle O1 is going to be 39 times 2, which is going to be 78, I think. You guys can correct me maybe if I'm wrong. We say that angle is equal to, I'm sorry, this angle is equal to 78 degrees, angle at the center theorem. So do you all guys get it? Or there's someone who's lost?
Yes, sir.
Yes,
You
sir.
lost?
No, sir.
No
Oh, okay,
confusion, sir.
okay, thank you. Then 9.1.2, determine the size of angle O2, whereby we can see that angle O2 is that one right there. So how do you guys think you're going to find that angle O2 there?
So it's 78 degrees because
Okay.
equal subtend equal angles.
She's saying that angle is going to be 78 degrees, and then reason is saying equal chords subtend equal angles. Do you guys agree to that?
Yes, sir. I agree with that.
Okay. Is there anyone still confused so that I can maybe clarify?
So could you explain it?
Okay. Remember we had that theorem that had 2 triangles inside each. It was like this, that theorem. It had something like this. Then if it is given in this theorem that this chord and this chord are equal, that implies that this angle right here is equal to this angle, reason being equal chords, this equal chord subtend those equal angles. And you need to note that those chords, we said they are equal, then we just go straight to the angles that are opposite that chord that we are talking about, and then those angles are going to be equal. Reason being equal chords subtend equal angles. Do you get this?
Yes, sir.
Yes, so it's the same thing. It's just that in this case, it happens that our angles are at the center, but still we've got those equal chords. And then when we go directly to those angles that are opposite the chords that we are talking about, we go straight to angle O1 and angle O2. Therefore, angle O1 and angle O2 are equal because equal chords subtend equal angles. Do you guys get that?
Yes, sir.
Can we now proceed to the next problems?
Yes, sir.
Okay,
Yes, sir.
let me try to find maybe something challenging. Sorry for that. I think we can maybe. Can you all see my screen that side?
Yes, sir.
Yes, sir.
Okay, I think we
Yes, sir.
can do as many questions as we can today with today's lessons before we can proceed to other things. So we have got that question 9 right there in front of us. So we can just together read the statement whereby they are saying A, B, C, it's a semicircle. They are telling us, okay, that implies something. What do you guys that implies on this diagram?
A to B is a diameter.
A, B is the diameter, okay, and then what do you think we can come up with from that statement?
Angle ACB is equals to 90 degrees.
Absolutely correct. Yes, this angle is going to be 90 degrees. This angle right here is going to be 90 degrees because this is our semicircle. This is the triangle we're talking about. Okay, that's correct. And then AB is produced to K, okay, such that KCS is a tangent. That also implies something, okay, to the circle at C, at point C. This tangent touches this circle at C. So SO or so. Is it so? Okay. SO, not so. SO is perpendicular to AB and KCB, and KCB is equal to 25 degrees. Okay, then we can go for DRCPT. Sorry, DRCPT. So, okay, we talked about the diameter that, okay, this is our diameter, therefore that angle is 90 degrees there. Then we are done with this. Then is there a radius, guys, on this diagram? Hello, guys, is there a radius in the diagram?
Yes, sir.
Which one is it?
Yes.
AO, AO and AOB.
Oh, let me just use different colors saying AO and OB. Okay, is that all?
And also CO.
Oh, CO. That implies these are equal. Therefore, this angle is going to be equal to that angle, right? And then this angle here is going to be equal to that angle because this line is equal to that angle. That line, I mean, is an isosceles triangle. Then we are done. Okay, we also have this radius, but okay, I don't think this matters because there is no point here. Okay, we are done with the radius. And then, is there a cyclic quad?
No, sir.
Okay,
No, sir.
then we can just simply pass that. Are there any parallel lines?
No, sir.
No, we can simply pass that. Is there a tangent?
Yes.
Yes,
Oh,
sir.
yeah.
Yeah.
This tangent, and then we know, according to tan chord theorem, this angle is equal to that angle. Excuse me. And this angle here is going to be equal to this angle right here, B1. And then also, since we said this is the radius, we know that implies that the radius is perpendicular to tangent. So, okay, at least that information is going to help us a lot. Then let's go to the question and see if we're going to come up with something. We have 9.1 is saying, give the reason why now. Okay, we already have the size of CAB curve, CAB. Then give a reason why you guys are saying angle CAB is equal to 25 degrees. They are saying already this angle here is 25. So what do you think, guys, is the reason for that?
Because of the tangent.
Tan chord theorem. Yes, that's true. Is there anyone who's still lost? Who's maybe curious? Or how come?
Yes, sir.
You're lost.
A little.
Okay. No, it's fine. Okay. Do you understand tan chord theorem?
Yes, I do.
That's tan chord theorem is like this. This is the triangle. Then if we are talking about this angle, that is between the tangent and that chord, you are going to go to the angle that is opposite this chord of focus, which is that one right there. So this angle here is equal to that angle there. Okay, then in that diagram of ours there, we said this is the tangent, right? And then this is the triangle. Then we're already given that this angle is 25. This is the chord. When you go to the angle that is opposite this chord, which is that one right there, is going to be 25 degrees. Reason being tan chord theorem. Can you now see it?
Yes, I do. Yes.
Are you sure?
Yes.
Okay, thank you. Then we can proceed to 9.1.2. OCA angle of CA is angle OCA, which is this angle right here. And then they are saying that angle 2 is equal to 25 degrees. So what do you think is the reason behind that statement?
Angles opposite equal sides.
Okay, yes, angle opposite equal side, because that angle is opposite that radius. Also, this angle is equal to, is opposite this side. Okay, that's correct. Do you all guys understand?
Yes, sir.
Is there no one who is still curious or behind? Are we all in the same boat, guys?
Yes, sir.
Yes, we are.
Okay.
Yes, sir.
Okay, thank you, guys. We can go proceed to 9.2. This one right here is saying, prove that CTOB, this one. Now we want to prove that this is a cyclic quadrilateral. So if you want to prove something, you first need to know the properties of that thing. And we want to prove that CTOB is a cyclic quad. We know that the properties of a cyclic quadrilateral, the first property is that opposite angles of a cyclic quad are supplementary, meaning they add up to 180. So in this case, it's either, if we can show that when you take this angle, you add to that angle, you get 180 degrees. Then you can conclude by saying CTOB is a cyclic quadrilateral. Or if we can prove that this angle plus this angle is equal to 180 degrees, then we can conclude by saying CTOB is a cyclic quadrilateral. Or if maybe by any chance you can maybe construct a circle here. Let me use a different color. A circle here, because remember a cyclic quad is a quadrilateral with all four corners of it on the circumference. If you can show that this angle is equal to this angle, then that will be the converse of the reason that is saying the exterior angle of a cyclic quad is equal to the interior opposite angles. That will be it, guys. So let's get into the question. How do you guys think we can approach this question using the properties of a cyclic quad?
Sir,
Yes, sir.
say that angle ACB is equal to 90 degrees because what's a triangle in a semicircle?
Yes,
think.
that's correct.
And
Yes, yes. No, you're correct. You're correct with your thinking.
And then, sir, angle TOB is equal to 90 degrees because angle's on a straight line.
Yes, okay.
And then you can say that, therefore, TOBC is a cyclic quad because opposite interior angles are supplementary.
Yes, that's correct. Do you all guys get that?
Yes, no, no,
You
please.
guys are not. Okay. Let me try to do this. Okay. Did you get me when I was saying in order for you to prove something, you need to know the properties of that thing? Did you get that point?
Yes, sir.
Yeah. And then now we said the properties of a cyclic quad. If this is a circle, and then this is a cyclic quad, the first property that we know, this is A, this is B, this is C, this is D, is that when you take angle A, you add angle C, you are going to get 180 degrees because opposite angles of a cyclic quad are supplementary. Do you agree to that?
Yes, sir.
Yes. Or maybe you can say angle B, you add it to angle D. If you get 180 degrees when you add those two angles, then that quad is a cyclic quadrilateral. Or there is also this theorem here. If we can extend the line here, that this is our exterior angle is equal to that angle. If you maybe can let that angle be x and play around your theorems such that at the end you're going to end up having x here. That is going to be the converse of the theorem that is saying exterior angle of a cyclic quad is equal to interior opposite angle of a cyclic quadrilateral. Therefore, ABCD is a cyclic quad. So someone in the room said, in this diagram that we are having on the screen here, this one, since this is the tangent, okay, sorry, not the tangent, since this is the semicircle, this angle is 90 degrees. Reason being, angle in a semicircle. So that angle still belongs to the diagram of focus, okay, of which is cool. Do you guys get that?
Yes, sir.
Yes,
Okay.
sir.
Then now you go to the angle that is opposite that angle that you already found, which is this angle right here. The statement there here already told us that this line this one is perpendicular to this one. That implies that this angle or this one is 90 degrees. Therefore, it is given that this is 90. Therefore, you can conclude by saying now the sum of angle T O B, I mean, plus that T C B, okay, this is 90. You said you agree that this is 90 plus this is 90 as well. We are going to get 180 degrees. Therefore, we can now conclude by saying this is a cyclic quadrilateral because these opposite angles gave us 180 degrees. Do you guys now get it?
Yes, sir.
Yes, sir.
Are you sure? Are you all sure?
Yes, sir.
100%.
Okay.
Can you explain again?
Okay, no, it's fine. So, do you understand me when I say, in order for you to prove maybe something, let's say this thing and our object is object A. So if you want to prove that object A is a car, you need to know the properties of a car. You get that point, right?
Yes.
Okay. So now here we want to prove that CTOB is a cyclic quadrilateral. So in order for you to prove anything that thing is a cyclic quadrilateral, you first need to know the properties of the cyclic quadrilateral. Do you get that thing, that part?
Yes.
Okay. Now I'm asking you this question. What are the properties of the cyclic quadrilateral?
Sir.
Yes, sir.
The opposite sides of a cyclic quadrilateral add up to 180.
Yes, that's correct. So does he understand that?
What did he say?
He said the opposite angles of a cyclic quad are supplementary, meaning when you take the opposite angles of a cyclic quad and then you sum them up or you add them, you're going to get the outcome of 180. Do you get that?
Oh, okay. Yeah.
Are you sure?
Yes.
Okay, so that's one of the properties of a cyclic quad. Then I say to you again, if this is a cyclic quad, and then if you have shown that this angle is equal to that angle, then you can use the converse of the reason that is saying exterior angle of a cyclic quad is equal to the interior opposite angles. So I'm asking you again, you who said you want me to clarify again. So our focus is here on this quadrilateral, right?
Yes.
Yes. Now I'm asking you, what is the size of this angle?
90.
Why are you saying it's 90? And now we want to know the reason behind that. Why are you saying it's 90? Because of the theorem, angle in a semicircle. This is the semicircle, so that angle right there is 90 degrees. Do you get that?
You said angles in a semicircle.
Yes, angle in a semicircle.
That's the only reason.
Yes, it's a theorem that if we have got a circle and then you have got a diameter, let's say this is our diameter here, and then you've got those chords there, let's say this is A, this is B, then BC is the diameter in this circle that I've drawn here. Can you see it?
Yes.
Yes. That theorem states that this angle right here is 90 degrees angle in a semicircle. Then to prove this, you know that this angle is 180 degrees is a straight line, right?
Yes.
So using that theorem that is saying angle at the center is 2 times angle at the circumference, that will give us this angle as 90 degrees, because we are going to divide this angle by 2. 180 divided by 2, then we get this 90. Then this will take us to that thing up there. Do you get it?
Okay. Yes.
Are you sure?
So you said you divide. Didn't you say that the angle at the circumference is 2 times the angle at
Okay, okay. Hear me out here. I'm saying, let me redraw this again. I've got my diameter here, right?
Yes.
This is A, not H. B, my diameter is AB, right?
Yes.
And then we have got an angle there, FC. This is the point O, the center. So I'm saying to you, okay, in fact, I'm asking you now, I'm not telling you. What is this angle here?
180.
Okay, it's 180 degrees. So what is this angle here?
90.
Why 90? Okay, this is where I wanted to explain the angle at the center is 2 times angle at the circumference thing. I'm saying you divide now because you want that angle at the center. We want angle C. And then angle O, let's this angle at the bottom, maybe O1. In this case, angle O1 is going to be equal to 2 times angle C. Do you agree to this? So we already have O1 as 180 degrees. We just want to find that angle C. That's where we are going to divide by these two, because we want that angle at the circumference, not the angle at the center. Therefore, angle C will be 90 degrees. Do you now get it?
Yes.
So now this theorem is the one, this theorem is the one that we are talking about here. This is this circle, this is the diameter. This is this triangle here, this one. Therefore, this angle that we are saying is 180 degrees at the center implies that 90 degrees at the circumference. Do you get that?
Yes, I do.
Okay. Then we said the focus now of the quadrilateral that we are talking about is this one. And then the theorems of a cyclic quad, we want to show that the sum of the opposite angles are supplementary. So we want to focus on the angle that is opposite the one that you already have, which is this one right here. Do you get that part?
Yes.
Okay, so we already shown that this is 90. What is this angle here? Sorry. What is this angle here? I'm now asking you, what is the size
90.
of why 90? What's the reason behind that statement of you saying it's 90 degrees? Excuse me. Okay, to save time, the reason why we say this is 90 is because we are given from the statement here that SO is perpendicular. So if I say to you, this line is perpendicular to this line, I'm saying to you, where they intersect or where they meet at the angle of 90 degrees. Do you get that?
Yes.
Okay, then since we are given that this is 90, we've shown that this is 90. When you add the two, you get 180 degrees, which is one of the properties of cyclic quad. Therefore, CTOB is a cyclic quadrilateral. Do you now get it?
Yes, sir.
Are you sure?
Yes.
Okay. Is there anyone who is still curious with 9.2, or we can proceed to 9.3?
We can proceed, sir.
Are you all sure that you can proceed?
Yes, sir.
Yes, sir.
Yes, sir. Okay. I think you're all sorted. Then write down with reason the size of angle COB. C is here, OB, COB, which is this angle right here. How do you think we are going to find that angle, guys? Oh, I think it's easy. Not that horrible. How do you guys think? I think we did something similar before. Yeah. How do you think?
So, sir, can I
Yes,
try?
ma'am. Yeah, you can give
So,
it a try.
okay, so you remember we said A and C2 is 25 degrees, right?
Yes.
So that would mean that ACO, AC like ACO, AO1 and 2, right?
I
So
go
it
what?
would be
A.
AC and
Okay,
O,
ACO. Okay.
yes, would equal 180 degrees because of angles in a triangle, right? So then if we add it together, would get 140 and we subtract it, we'll be left with 40 degrees. And then we said O2 and O3 should equal to 90 degrees. So we say 90 degrees minus 40 degrees to get O3.
Yeah.
Yes, sir.
Okay. That's a good try. Okay. There's other approaches that we can use. Good one.
Sir, can I
But yes, you can give it a try.
secondly the theorem that states that the angle at the center is equal to the angle at the circumference?
Yes, you are going to get the same answer because angle O3 is 50 degrees. Yes. So is everyone okay with that answer for 9.3?
Yes, sir.
Okay, then you can also use that exterior angle of a triangle, O3 is equal to the sum of that A and C2. Okay, we can go to 9.4, which is the last question of question 9. Then prove that now, okay, where is okay? Okay, is this one, is a tangent to a circle that passing through sock that passes through this. Okay, interesting. So how do you think, guys, we are going to show that this is the tangent to this circle? Let me make it a little bit neat.
Sir,
My circle is horrible. Okay, ma'am, yes?
I proved that angle S is equal to angle O3. And
Okay.
then I got then the reason why OK is a tangent is because of the converse of ten-chord theorem.
Ten-chord theorem. Then how did you show that angle O3 is equal to angle S? Because I think you need to show some working, have some working, use theorems, play around them.
Okay, so I found angle C1, which is 65 because of angles on a straight line.
Okay, that's a good approach. I love it.
Thank you, sir. Then I found angle S, which is 50 because of interior angles of a triangle. Then therefore angle S and angle O3 are equal. Therefore, OK is a tangent because of the converse of 10 chord
Of a
theorem.
time chord theorem. That's absolutely correct. Full marks. Is there anyone who is lost with this question so that you can just work around it?
Sir, can I ask which triangle she's referring to when she says angle of a triangle?
Okay. Let me do this. Use maybe a red card, I think it will be bold enough. So we are talking, okay, we want to show that, okay, this is okay, right? We want to show that this is a tangent to this circle that passes through S. It comes to O after S. Here is O. Hey, my circle is beautiful. To C from there. Then this is the circle. And then we can also see that inside this circle of ours, we have got this triangle. Can you see it?
Yes.
Yes, that's the triangle. That's the triangle that she was talking about. She showed that this angle is equal to that angle.
Oh, okay.
So do you all guys understand how she did it?
Yes, sir.
No, sir.
Okay, can anyone who understands explain it to her, please?
Okay, so if you look at the circle that Sir drew, the red circle, right? You have a triangle that moves from OS to C, right? Then
Yeah.
then there is this line ACS, right? Then you have the angle O, the 25 degrees O3, O2 that you have already calculated. Then you use angles on a straight line to find C1 within the circle that Sir drew,
Yes.
right? Then
Yes.
then you find angle S because of interior angles of a triangle, which is then going to be equal to O3.
Yeah, I think I understand, my dear teacher.
Okay.
It's clear to me as a student. I don't know about others. You're
Do you
still lost?
Understand?
Do you
okay?
understand?
Yes.
Are you sure?
Yes.
Oh, okay. I know, guys, that is time over. Can I just take it maybe at least maybe 5 minutes to do maybe this one with you?
Yes, sir.
Yes, sir.
Is everyone fine with that?
Yes, sir.
Okay. I think this is very, very simple. We're just going to play around Doctor's Cape Town to just find the size of the angles. Because tomorrow I just want us to work these kind of questions, the ones that are saying we have to prove. Today we'll just go through these ones that want us to calculate the size of the angle. So to work around this one, let me do this. DRCPT. Okay, and then read my statement. They are saying in the figure below, ABCD is a cyclic quadrilateral. Wow. That gives us something. In a circle centered at O, and the triangle DOP, okay, I can see is drawn. DS is a tangent to the circle at D, and then you're given also that BC is equal to DC. Okay, then the last part is CDS is equal to 40 degrees. Then going to our Dr. Cape Town, guys, is there a diameter on the circle?
Yes, sir.
Where is it?
No, sir. No, sir.
Oh, yes. I was shocked. Okay, there's no diameter. Is there a radius?
Yes, sir. 2.
Okay, 2 of them. Then what does that imply?
So implies that there are 2 equal angles.
Yes, that implies that this angle is equal to this angle. Okay, and then we are done with the radius. You can go to C, which is the cyclic quad. Is there a cyclic quad?
Yes, sir.
Okay, which is A, B, C, D. We are given that. Therefore, that implies that when we add angle A and angle C, we are going to get 180 degrees. Same applies when we add this and this, you're going to get 180 degrees. Okay, we are done with C. Are there any parallel lines?
No.
Okay, no, they're not. Then we can just cross
No,
that
sir.
out. Is there a tangent? Yes, there's a tangent there. And then there's this angle, there's this triangle, then this angle is equal to the angle opposite the chord, which is this angle. Okay. And then also, this is the tangent, that is the triangle. This angle is equal to that angle. So let us just dive into the question without wasting any time. So 811 is saying calculate with reasons the size of BDC, and then BDC is this one right here, BDC. So how do you think, guys, you're going to get your 3 marks? That's a good mark. How do you guys think you're going to find that angle C?
Sir, can I try?
Yes, you're more than welcome to give it a try.
Okay, so we can see that angle D1 is equals to angle B1 because of the 10-chord theorem.
Oh, you are saying, sorry, angle D1 is equal to that angle. So you are saying that angle is equal to 40 degrees, right?
Yes.
It's tan chord. Okay, I agree. Yes, and then?
And then angle B1 is equals to angle B2 because of angles opposite equal sides.
Yes, is 40 degrees, then you can say isosceles triangle. And then?
Therefore, angle BDC, which is D2, is equals to 40 degrees.
Sorry?
I'm saying angle D2 is equals to 40 degrees.
Okay, yes. And then now what do we do afterwards?
We can conclude that angle BDC is equals to 40 degrees because of angles opposite equal sides.
DC. Okay. Yeah, that's correct. Oh, my bad. I thought you were calculating angle C. Okay, the angle C is the next one. I'm sorry for that. Then, do everyone understand how we found that angle BDC? Oh, is there anyone who's still curious? No? Seems like I'm left alone. Hello, guys. Do you all understand 8.1.1?
Yes,
sir.
Yes,
sir.
sir.
Yes,
Okay, guys, thank you. Please, you guys, give me a feedback whenever I request it. Then, how can we find now angle C?
So,
Yes.
we can find angle C through sum of angles in a triangle, since we have B1 and B2.
Supplementary. Then you are saying this plus this plus this is equal to 180 degrees. Then 180 minus this, you get this.
Yes, sir.
Okay, do you all understand that? No
Yes,
feedback.
sir.
Yes.
Okay, thank you. Then the third one, we are now looking for the angle A, which is this one right here. How do you guys think you're going to find that?
Opposite angles of cyclic.
Sorry?
I said opposite angles of cyclic quadra,
A,
meaning
a supplementary. Okay.
yes, sir.
Okay.
Meaning angle C plus angle A will equal 180. I think we said angle C will be at 100. Meaning angle A will be 80.
Angle A will be 80.
Yes, sir.
Let me, okay, can I just please confirm this? 180 minus 40 minus 40. Oh, okay, yes, I agree. That's correct. So is everyone understanding that?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
thank you. 8.1.4, which is the last one, we are looking for the size of angle O1. O1. How do you guys think we are going to find angle O1?
Angle O1 will be you said angle O1 is 80, right? Meaning the angle in the middle will be 160. Reason being angle same circle equals 2 times angle on angle first center equals 2 times angle on circle.
Circumference, yes.
Yes, sir.
That's absolutely correct. So is everyone understanding what we just did now?
Yes,
Yes,
sir.
sir.
Yes,
Yes.
sir.
Yes, sir.
Okay, guys, thank you. So here's the thing. Today, I'm not going to give you guys the homework or something to do at home. Instead, do you guys practice after these lessons or maybe on your own time when you have some time?
Yes, sir.
Yes, sir.
Okay, so if maybe by any chance it happens that maybe when you practice at home, maybe tomorrow, maybe tonight after this session or anytime, you find a challenge with finding maybe some other angle that you are required to find on Euclidean geometry, just keep that question and just send it to Mr. Desmond so that he can drop it to the group. Then with the next session, so that we all in the room can just work those problems around. But then if you don't have those problems, then I think next time what we are going to look is to look on those questions whereby we are required to prove something. Maybe we are required to prove that a line is a tangent to a circle, to prove that a quad is a cyclic quad, to prove that maybe something is an isosceles triangle. That's what we will do with the next session. If maybe you don't have some other problems that you have encountered with the problems that you will be doing after this session. Is that okay?
Okay. Yes, sir.
So is there any other question now regarding the lesson that we had today?
Yeah.
Yes, ma'am.
It's more about the lesson yesterday, but about the questions we can send to Desmond.
Sorry?
Can you send like questions from the paper 2 topic, the triangles, if you don't understand something, or we only based on the circles?
You want to send some questions? I don't know
Yes,
if I
sir.
understand you.
The triangles, the proportionalities in triangles, those type of questions.
The one for proportionality?
Yes, sir. Can you send them, or we only dealing with circles right now?
How about if now, because my plan was I want us to just do this question whereby we are required to find the angles. we finish those questions. Afterwards, we go to those questions whereby we are required to prove some things. After we are done now, that is a grade 11 Euclidean geometry. After we are done with grade 11 geometry, then that's when we are going to start Euclidean, grade 12 Euclidean geometry for proportionality. And then I think that's when we can take those questions and onwards. Is that fine?
Okay. Okay, sir.
Yes. Is everybody fine with that?
Yes, sir.
Yes.
Yes, sir.
Yes,
Okay, guys, then I think we can end here for today and enjoy your night. Thank you once again for being with me tonight.
Thank you, sir.
Thank you,
Thank you,
ma'am.
sir.
Now I'm out. Stop sharing.